A manufacturer estimates that if each shipment of raw material contains X units, the total cost in dollars of obtaining and storing a year's supply of raw materials will be C of X equals 2X plus 80,000 divided by X. Find all vertical and horizontal asymptotes of C of X. Note that as X gets larger and larger, the term 8,000 divided by X gets smaller and smaller. What does it say about the relationship between the curve C of X and the line Y equals 2X? Sketch the graph, and I did that for you already. What this brings into play is an idea that we had in college algebra called oblique asymptotes. And that's what this problem ends up bringing up more than anything else. Now, an oblique asymptote is of the form y equals mx plus b. It is a degree 1. It is a line. An example would be f of x is equal to x squared plus 2x minus 5 divided by x minus 3. This guy has an oblique asymptote. And you'd say, why is that? Because if you look at the model, because we always go after the model when we go after the asymptote. The model is x squared over x, which is x. It's degree 1. So that as x goes to infinity, well, let's do it in calculus. As I take the limit as x goes to infinity, x itself goes to infinity. Because it's not in the denominator anymore. So that's the model. So if I were to go to graph this guy, need to remove my plots, and I'm going to put in x squared and I made it up plus 2x minus 5 divided by x minus 3 and I don't know where this graph is, so I'm just going to do a zoom standard, zoom 6, bring it up on the standard graphing window. But I don't have now the whole graph, so I'm going to do a little bit of a trace. And now what does a trace do? So I watch the x and y values, and as we shift to the other side of that vertical asymptote, that's going to give me y values. And notice I'm up at 21. So that says if I take my y window and I say raise it to 50, at least I'm going to get some of the graph. So what you notice is that there's going to be a line that's going to essentially shape this out. So if I were just to put in, say, y equal x, which is not, by the way, what it is, I don't think, you're going to see it's going to run parallel to it. I need to shift it up just slightly. I can't do it that way. And how do we do that in college algebra? Well, you actually found it by taking x minus 3, dividing it into x squared plus 2x minus 5. So this would be x squared minus 3x. This is a 5x, so that's going to minus 5. That becomes a plus 5. And it's x plus 5. There it comes.
Do we need to know synthetic division for this?
You can do it synthetic if you want, or you can do it long. Doesn't matter with what we do, it doesn't really matter. Now, from a calculus point of view, you notice how essentially the asymptote is not horizontal. They call it a slant asymptote. So what I can't do in college algebra is finish the problem. And this is a 10, a remainder of 10. So you would say that f of x, whoops, sorry about that, f of x can be written as x plus 5 plus 10 over x minus 3. Because I long divided it out. If I take the limit as x goes to infinity of x plus 5 plus 10 over x minus 3, where does that go? As x goes to infinity, 10 over x minus 3 goes where? Where's it go? Break this up as the limit as x goes to infinity of x plus 5 plus the limit as x goes to infinity of 10 over x minus 3. Where's that go? 10 over infinity minus 3 is 10 over infinity, which is what? 0. This goes to 0. And what you're left with is x plus 5. Is x plus 5. Because x plus 5 is going to infinity, this thing's going to 0. What's left is x plus 5, which goes to infinity. It's a quotient. So that's your oblique asymptote. Your model is degree 1. So that when they come back here and say find all vertical and horizontal asymptotes, where c of x equals 2x plus 80,000 divided by x, right? Well, you have a VA at x equals 0. That's clear from here. And then you look at the model is 2x. That's linear. And you say, well, what do you mean by that? The model is 2x. Well, let's take this. 2x plus 80,000 divided by x. Put it over a common denominator. This is 2x squared plus 80,000 divided by x, right? What's your model? It's an oblique asymptote because your model is linear. So if you take the limit as 2x goes to infinity, it's going to go to infinity. What this tells you is that the slope of that asymptote is 2. This is the first part. What you don't have, like I had to do to adjust the asymptote I found, I actually had to go find it because that y equals x had to be adjusted up 5 units in order to actually be the actual asymptote. This tells me essentially that it's 2x plus some constant or minus some constant. So if that is the case, it has no HA. if I take the limit for n behavior as x goes to infinity of 2x plus 80,000 over x, what happens? This thing goes where? 0. So they're saying, what is the relationship now between that and 2x? It has an oblique asymptote. It has an oblique or slant asymptote. That's the calculus part of an algebra problem, which we don't do in algebra. We just kind of wave our hands around it. And that's what it looks like. Here's the graph. And then what you notice is there's y equals 2x. There's your oblique asymptote. That's as exciting as this problem gets.